Yes, hello students. So we are going to start today partial differential equation. Basically, you should remember what things we have done in this partial differential equation. We have come across eliminating arbitrary constants. If we take any x and y be independent variable, then how we are going to form partial differential equation we have seen, and in this class I will be telling you how partial differential equation is being done and how we are going to eliminate the arbitrary constants, arbitrary functions, and simplifying the PDE. So there are again various types like non-homogeneous equations are there, and how we are going to form the PDE, that is also very important. And next is homogeneous equations, how we are going to form the PDE, that is also very important. So there are some few concepts today I'm going to explain you. Okay, so we'll start with our presentation. Yes friends, so you can just see partial differential equation. In this first we already discussed about what is the limit, definition of the derivative f dash of x. So I already told you how f dash of x is being represented. So you can just see how to represent f dash of x. So this is simply written it as dou f upon dou x. It is also written as fx. Is it clear? It means that you are differentiating partially with respect to x, keeping in mind that y is constant. Is it clear, students? So these things should remember. And when you are doing again differentiating partially with respect to y, that time this f dash of x is nothing but dou f upon dou y is equal to fy, keeping remember x is constant. Is it clear, friends? So these things you have to remember. And very important, what is the definition? Yes friends, so what definition says? Definition of partial derivative of a function of two variables. If f is a function of two variables, its partial derivative are the function fx and fy, defined by fx x comma y is equal to limit h tending to 0 f of x plus h comma y minus f of x comma y divided by h. Fy x comma y is equal to limit h tending to 0 f of x comma y plus h minus f of x comma y divided by h, provided the limit exists. Notation, please remember the notation, students. If z is equal to f of x comma y, we write fx x comma y is equal to dou f upon dou x, which is dou z upon dou x, which is nothing but just d of fx. So this is how we denote write the notation. So how we read this symbol? Yes, please remember the partial derivative of f with respect to x. So please remember this dou f upon dou x. How we read this? Partial derivative of f with respect to x. Next we see what is del of f, del of x, partial f, partial x, partial derivative of x in x. So this all are same. Finding partial derivative, we have seen the partial derivative with respect to x is just the ordinary derivative of the function of a single variable that we can keep y fixed. Rules we have already seen. So there are only two rules. If you are differentiating with respect to x, y is constant. When you are differentiating with respect to y, x is constant. So we have seen what is the function. This is simple function f of x comma y is equal to 3x minus x square y plus 2x cube y. This is simple functions they have given. So this may be homogeneous, non-homogeneous. So that is what we are going to discuss today. Then partial derivative at a point is defined as f of x a comma b is equal to limit as h tending to 0 f of x plus h comma b minus f of a comma b upon h. Similarly for y, then we have taken one example, very simple example we have taken. If f of x comma y is equal to x cube plus x square y cube minus 2y square, we have seen find fx 2 comma 1 and fy 2 comma 1. We have taken solution and we have simplified and we have calculated the answer. Fx 2 comma 1 is equal to 16, fy 2 comma 1 is equal to 8. So differentiation is different for with respect to x and with respect to y. So we have seen another example from PDE. This very simple equation from the following equation: z is equal to x plus by plus ab. So we have just considered this equation 1, differentiate this partially with respect to x, we just get dou z upon dou x is equal to a. Again when you differentiate this with respect to y, dou z upon dou y is equal to b. So where y is constant and here in this equation x is constant. Put equation 2 and 3 in equation 1, we get this z is equal to xp plus yq plus pq. So this is very simple example we have done, and we have seen you have to try some more examples in this students. Okay. So this is very very important, just try yourself students. I will share the PPT and even in the link you will get this PPT. Just click on that, you will can download the PPT. And first example I have done from PDE. So here we have considered the equation, differentiated with respect to x, we have calculated this a is equal to 1 upon z minus b, and again once again I have differentiated with respect to y and substituted a is equal to 1 upon z minus b. I have calculated q is equal to p divided by z minus b, where how the PD is formed, p 1 plus q is equal to zq is the PD, where z is equal to a function of x comma y, dou z upon dou x is equal to p, dou z upon dou y is equal to q. Similarly I have taken the second example from PD, ax square plus by square plus z square is equal to 0. Here I have taken ax square plus by square plus z square is equal to 0. Differentiate this with respect to x partially and eliminate the constant term ax square. I have substituted this ax square is equal to minus x zp. Similarly differentiate this with respect to y partially, keeping x as constant. Here again I have simplified this by square is equal to minus y zq, and then form PD z is equal to xp plus yq. So very simple. Then we have seen some more examples with functions. Yes, z is equal to, you can see f of x square minus y square. The first example, consider the equation, differentiate this with partially with respect to x and y. So in this example we have taken only simple equations, quadratic equations there, and we have eliminated the constant terms. Here we can see students z is equal to f of x square minus y square. Here please see that this is a equation, we have to eliminate the arbitrary function. So I have to eliminate this f of x square minus y square. Therefore I have differentiated this with respect to x partially, differentiate partially with respect to y, simplify. I have calculated this py plus qx is equal to 0. So I have eliminated here f dash of x square minus y square. So this is how we have to eliminate the arbitrary constant and arbitrary functions. So these are some simple examples. I have given it as homework, very very important. Please consider this example for your final exam also. Then next, I have taken one simple example, z is equal to f of x plus ay plus g of x minus ay, which is 1. Differentiate partially with respect to x. I have calculated this as r is equal to 1 upon a square, dou square z upon dou y square. Similarly in the left hand side we have differentiated partially with respect to y, and I have calculated this as 1 upon a square, dou square z upon dou y square, that is t. So you can see in this 3 and equation 5 LH is the same, so therefore I have equated and calculated r is equal to 1 upon a square. T is nothing but the partial differential equations. Next we have seen the solution of partial differential equation of non-homogeneous equation by direct integration. Some of the partial differential equation can be solved by direct integral, as we have seen. While integrating with respect to one independent variable to the other independent variable, the other independent variable are to be considered as constant, and constants of integration has to be taken as arbitrary functions of variable considered constant. So one example we have taken here, students, that is solve dou square z upon dou x square is equal to xy. Consider this equation, integrating this with respect to y, and also same equation I am integrating with respect to x. So we can see integrating partially with respect to x, it is also known as, we can just integrate this, and this is what we get the integration. Very simple integration. Use the formula, and right hand side I have given the formula. Then some another two examples I have given. Please try this examples yourself, students. If you don't get, please come to me and I will solve it separately. Yes, then so this is a quick introduction and revision of our class we have done. Now I am going to start with the solution of homogeneous partial differential equations involving derivatives with respect to one independent variable. So this is very, very important. I think anybody has entered? If anybody has entered, just tell me. Fine. So here I am going to consider, this is equations what we are going to consider today is also homogeneous partial differential equation. Is it clear? So one example I will do it, and we see how these examples can be solved. Okay, so here we start considering the example. Please write down the example. First example, example 1. Just don't select the pen. I don't know why this pen is not.
10:55 as it is ಇಟ್ರೆ ಅದಕ್ಕೆ 1:30 as it is ಅರೆ 1:30 ಯಾವುದು ಸೊ 1:30 ನೀವು ಅದರ ನಿಮ್ಮದು ಯಾಕೆ
Just a minute, this pen is not writing.
ಅವರು ಭಾಳ ಯಾರಿಗೂ ಸಲಾಮ್ ಕೊಟ್ಟಿದ್ರು
ಕಾಲೇಜಿಗೆ ಹೇಳಿದ್ದೆ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೊಂಡು ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತದೆ. ಇವರು ಚಲೋ ಇದ್ದಾರೆ ಎನ್ಸಿದವರು
ಇದಾಗಿ ನನ್ನ ಪಾಪ ಅವ್ರಿಗೂ ಆಗುದಿಲ್ಲ ಅವನು
ದೇ ಆರ್ ಗುಡ್ ಎನ್ಸಿದವರು ವಿಕಾಸ್ ಸರ್
ನಾನು
ಚೇಂಜ್ ಮಾಡ್ಕೊಂಡು
ಹೇಳ್ಬೋದು
ಹೌದು
ನನಗೆ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ನಾವು ತಗೋತಿದ್ದೇವೆ.
Now pen is selected. Okay, thank you. Yes.
ಕೊಟ್ಟಿಲ್ಲ 14 ಕ್ಲೋಸಿಂಗ್ ಇಲ್ಲ
Yes, students. So please write down the example. I don't know what is the problem, but here it is not writing. So it's pen.
ಸೆಮಿನಾರ್ ತಂದ್ರೆ ಸಬ್ಮಿಟ್ ಮಾಡ್ತಾರೆ.
Please write down the example. Solve dou square z upon dou x square plus z is equal to 0, given that when x is equal to 0 and z is equal to e raised to y, and dou z upon dou x is equal to 1. Yes, friends, so please write down the question and simplify this problem. So this equation is considered as homogeneous equation. One thing you should remember, any function f of xy is equal to 0 is always considered as homogeneous differential equation. The function must be, the equation must be equal to 0. Please remember this one. Then this equation is nothing but homogeneous equation. Okay, so just consider this. Mainuddin, can screen is visible? Please reply.
Yes, sir.
Yes, thank you. So write this equation. So in this class, today's class, this example is very important. So just consider this equation, dou square z upon dou x square plus z is equal to 0. So please remember this ones. I already described about what is the del. What is del? Del is nothing but, we just take this as some differentiation d is equal to dou upon dou x. So now I say I'm going to operate d. So d is nothing but d upon dx. So just simplify this. So here dou square upon dou x square is there, means what will be this equal to? Yes, Vishwajit, can you tell me what is dou square upon dou x square is equal to? Yes, students, please reply. Mainuddin, can you tell me? What is dou square upon dou x square? See, if d is equal to dou upon dou x, then what is dou square upon dou x square? Is it not d square? Yes? Oh, very good. So therefore I will write this now, d square z plus z is equal to 0. So first always you have to convert this equation into d form, that is using operator d. So then you can simplify this equation, d square plus 1 z is equal to 0. Now we are going to take the auxiliary equation. Auxiliary equation is, what is auxiliary equation, students? This d will be considered as yum, and then this equation must be equated to 0. Z cannot be 0, therefore automatically m square plus 1 is equal to 0. That implies m is equal to plus or minus I. Is it clear? So this is how we have to find the solution of auxiliary equation. Next, please remember, we have to also find complementary function. So here complementary function, what should I have to take? Yes, can anybody tell me? Yes, Anirudh, Milend, Vishwajit, which function should I take in this complementary function? Is it real or imaginary? Yes, can anybody tell me it is easy? It is real or imaginary? Yes, it is imaginary. Plus or minus I is imaginary. What is complementary function, students? CF is equal to C1 cos x plus c2 sin x. This is how we write the complementary function. Remember, in general, if such equations, if you get in terms of alpha plus or minus I beta, right, you may get, in this we have got alpha is equal to 0, but if in general if you get this alpha plus or minus I beta, then what will be the complementary function? That is very, very important. The complementary function, you should remember,
Monday 12.
ಇಲ್ಲ ಸರ್ 130
130
for one pair of imaginary roots, one pair of imaginary roots, yes friends, this will be CF will be equal to C1 cos beta x plus C2 sin beta x into e raised to alpha x. So this formula you have to remember for complex root. So this is a complex root. Is it clear, students? So then, comparing this equation with this, easily one can tell alpha is 0 and beta is 1. So then I have substituted this equation in this and written this complementary function. Is it clear? Now whenever, if you take this constant and if this is, just a minute, and if this is integration, then the constant should be written in this form. So just for our sake, we just take this complementary function is equal to f1 y cos x plus f2 y sin x. Why? Because students, please remember, since z is a function of x and y, and therefore I have taken this function f1 and f2. c1 and c2 are arbitrary function of y. So therefore I have simplified that z. So hence what is the solution, students? Solution is, this is our final solution. Complementary function, I will take here complementary function is nothing but our z. So therefore this is z is equal to f1 y cos x plus f2 y sin x. So this is how we calculate the value of z. Given, what is given here, students? In the question they have clearly mentioned z is equal to e raised to y when x is equal to 0. This is given in the question, students. You can just see here what is given. Z is equal to e raised to y, x is equal to 0. Okay, then dou z upon dou x is equal to this. I am going to substitute in the equation. Okay, so considering this equation 1, put in equation 1. That implies e raised to y is equal to f1y cos 0. Yes, Menudin, please tell me what is cos 0?
1, sir.
Yes, very good, it is 1 plus f2 y sin 0 is 0. Therefore if you simplify this, you will get this as f1 y. So therefore z is equal to e raised to y. Is it clear, students? So like this we get this equation, z is equal to e raised to y. f1 y, we consider this, so f1 y is nothing but e raised to y. So that implies z is equal to e raised to y cos x plus f2y sin x. Please remember here, students, I have eliminated this and simplified this e raised to y. Similarly, I have to eliminate now f2. Already I have told you arbitrary constant must be eliminated. How we can find the PD, students? Please remember in the exam also, if you get this equation, first you have to eliminate the arbitrary functions f1y and f2y. So f1y I have already calculated e raised to y. Now I am going to calculate f2y. To calculate this, what I will do, I will consider this equation 1. Consider equation 1. Z is equal to e raised to y cos x plus f2y sin x, and differentiate partially with respect to x. So let us see, can we eliminate the next part? Yes, easily one can eliminate f2y. So why we are doing this process? Because to eliminate f2y. Then now we simplify. This is dou z upon dou x is equal to e raised to y as it is, because here when we are differentiating partially with respect to y is constant. Please remember this, students. Therefore e raised to y is constant. I have taken it outside. Differentiate record
बंद झालं ते करा बंद केला का तुम्ही इसके लिए याले काय झालं त्याला की
Okay, now I'm going to eliminate z. So where is the equation? So we have calculated z is equal to e raised to y cos x plus f2 y sin x. So just differentiating this partially with respect to x, we get dou z upon dou x is equal to e raised to y. We have already done this, I am just repeating. Cos x differentiation is minus sin x plus f2y is again constant, so no change, and sin x differentiation is cos x. So here please remember y is constant. Is it clear? So what I have to eliminate? f2y. So I am going to substitute x is equal to 0. So when x is equal to 0, please remember, given in the question, dou z upon dou x is equal to 1. So that implies when I put this terms in the above equation, you can see this is 1 is equal to e raised to y, sin 0 is 0 plus f2y, cos 0 is 1. So that implies, you can see what is f2y. f2y is equal to 1. Therefore what is the solution, students? Solution is z is equal to e raised to y cos x plus sin x. This is PDE. Is it clear, students? If you have any doubt, you can ask me. So this is how we have to find the PD. Very easy, very simple. Only some calculations they have given little bit more. So one by one you have to take the examples and you have to try. So will you try the another one example taking homogeneous equations? Yes, students, will you try? Okay, another example I will give you. Example 2. Solve. Yes, students, very simple example they will give you. They just give solve dou cube z upon dou x cube plus 9 dou z upon dou x is equal to 0, given that z is equal to 0, dou z upon dou x is equal to 0, and dou square z upon dou x square is equal to 9 when x is equal to 0. Please write down this equation, students. Very important example. You may get this question for your exam. Okay, how to simplify I will tell you. It is little bit lengthy but not difficult. Is it clear, students? You have to just make it easy. Okay, I think you have written down the question. Solve dou cube z upon dou x cube plus 9 dou z upon dou x is equal to 0, given that z is equal to 0, dou z upon dou x is equal to 0, and dou square z upon dou x square is equal to 9 when x is equal to 0. So please try this example, students. Okay, so we'll solve this example. Now see here. First, let them give any equation, students. First you have to write it in terms of linear equations taking d is equal to dou upon dou x. So therefore the same equation I will going to write it in this d cube z plus 9d z is equal to 0, or I will take z common, so this is d cube plus 9d z is equal to 0. So whenever you get this equation, z cannot be 0, therefore what is 0, students? D cube minus plus 9d is equal to 0. That equation is nothing but auxiliary equation, we say. So what is auxiliary equation? This is d is equal to m, we substitute, and m cube plus 9m is equal to 0. This is how we have to simplify. This is our auxiliary equation. Now in this I will take common m on both. So m, if I take common, m square plus 9 is equal to 0. That implies we can see here, students, m is 0 or m square plus 9 is equal to 0. Am I right? So when m is 0, what is the complementary function? And when m is equal to, this is complex function, you can see here m square is equal to minus 9 and m is equal to plus or minus 3i. So square root I have taken on both the sides, so we get here complex root. So this type of example is very very important. See here, students, because m is equal to 0, we have got a real root and also complex root. Yes, students, so please tell me, when you get the real root, what is the complementary function? And when we get the complex functions, I already told you what are the roots. So two formulas I am going to use in this. Look on the screen. So I say that this, for m is equal to 0, complementary function will be equal to c1 e raised to alpha x. This is in general. And I am going to use another formula, complementary function, for complex roots, c1 cos beta x plus c2 sin beta x e raised to alpha x. These two formulas I am going to use the solution of this auxiliary equation. So please remember this formulas in your mind and substitute one by one. Now here m is equal to 0 means alpha they have given here 0 directly, therefore you can write the functions here directly, students. So complementary function is nothing but adding this both, this equation and this equation. So directly I will write this as c1 e raised to 0x. Is it clear? Plus, now when I go to complex function, students, this is alpha is equal to 0 and beta is equal to 3. So you can just compare this equation. Now alpha I will put 0 and beta is equal to 0. So complementary function I am going to add this as c2 cos 3x plus c3 sin 3x. So you may say c1, c2, c3, how it is coming? Please see that this is just a constant terms I have taken here. Is it clear, students? Okay, so now I will write this in z form. Z is equal to, now e raised to 0 is 1, so I will get only c1. So here I am going to put c1 is equal to arbitrary function. I already have told you f1 y, and c2 I am going to put f2 y, and c3 I am going to put f3 y. Okay, so therefore z is equal to f1 y plus f2 y cos 3x plus f3 y sin 3x. Is it clear? Now this is the solution, students, but see that they have given some conditions. Can Mainuddin tell me, using the conditions, what I have to do this equation? Yes, I have to eliminate f1y, f2y and f3y. Whatever the answer we get, friend, that is our final answer. To eliminate f1y, f2y and f3y, I am going to use the conditions. Using the condition, it is given in the question. Using the condition, z is equal to 0 when x is equal to 0, then I will consider this equation 1. So I will put it in this equation 1. So what I will get here, students? Yes, it is 0 is equal to f1y plus f2y. That implies f1y is equal to minus f2y. So this equation I am going to consider this as equation 2. So when you look at the question, z is equal to f1y plus f2y cos 3x plus f3y sin 3x, students, I cannot simply substitute further. So therefore what I do, I differentiate this with respect to x and substitute and see, do I get the values of f1y, f2y and f3y. This is very simple idea, students. Please remember this. Again I will repeat. Whenever z they have given, you have calculated the solution. After calculating the solution, if after substituting the conditions, here they have clearly mentioned, when you substitute the conditions and you don't get the answer, then here clearly mentioned you have to differentiate this with respect to x, then it is 0. Am I right? And when you differentiate once again, it is 9. Means this condition itself will give you how many times we have to differentiate. Can Vishwajit tell me how many times I have to differentiate z? Mainuddin, can you tell me how many times I have to differentiate looking at the given data? Yes, anybody else? Yes.
Sir, 2 times.
2 times. Very good. Excellent. This is what you should remember. Looking at the question only, given that z is equal to 0, first condition, without differentiating one value, you will get dou z upon dou x, you will get second. First differentiation, you will get second value. And third, dou square z upon dou x square is equal to 9. Using this, we will get third value. Means when you take z is equal to f1y, f2y and f3y, f1y is eliminated, f2y is eliminated and f3y is eliminated. You can see using condition 1, z is equal to 0, I have eliminated f1y as minus f2y. Okay, let us try differentiating this equation 1 with respect to x. Again I will differentiate with respect to y. One by one we will eliminate this function f2 and f3. Okay, so let us see differentiating. Okay, here I will start differentiating equation 1 partially with respect to x. We get, very simple, students, you have to understand. So dou z upon dou x is equal to, now here you can see, when you differentiate, f1y is constant, differentiation is 0, f2y is again constant, take it outside, only cos 3x. So differentiation of cos 3x is minus 3 sine 3x. Is it clear? Similarly, here when you continue, f3 y differentiation is constant, take it outside, only have to differentiate partially with respect to sine 3x, which is equal to 3 cos 3x. These two values I am going to substitute. Please note down this formula, friends, very very important. Therefore, dou z upon dou x is equal to, we get this as f2y minus 3 sine 3x, I am going to substitute, plus f3y as it is 3 cos 3x. So these two terms I have simplified. Now I will keep this equation number 3. Okay, so again I will differentiate, friends. Please remember, I have to calculate f2y and f3y, therefore I have to differentiate 2 times. It is understood looking at the question itself. Again I will differentiate equation 1, equation 3 partially with respect to x. We get what we get, friends. It is dou square z upon dou x square is equal to, again you can see f2y is constant, no change as it is, here minus 3 as it is, no change, into sine 3x. Sine 3x differentiation, we have 3 cos 3x. Please remember this chain rule, friends. Plus f3x is constant, so write f3x, f3y as it is. Again differentiate this now, 3 is constant, keep it as it is, into cos 3x, the differentiation is 3 sine 3x. Now when you simplify, minus 3 into 3 is 9, so I will write here minus 9 f2y cos 3x plus 3 into 3 is again 9, and differentiation of cos is minus, so therefore I will take here minus 3 sine 3x, therefore minus I will take it outside here, so this is minus 9 f3y sine 3x. I will keep this equation number 4. Now I will use the conditions. We have the condition. Once again I will write the conditions from the question. This condition you should not remember, it is already present in the question. So first condition I will take only dou z upon dou x is equal to 0 when x is equal to 0. Where I have to put? Can anybody tell me these two conditions where I have to put? Yes, anybody? Vishwajit or Mainuddin is there? In which equation? 3 and 4. Which equation should I put this? Dou z upon dou x is equal to 0 when x is equal to 0. Please think, students. Third equation or fourth equation?
So fourth one.
Yes, it is third equation, because you can see here we have dou z upon dou x. In the fourth equation, dou square z upon dou x square, but I am using only dou z upon dou x is equal to 0. So I am going to put this in equation 3. So therefore this is 0 is equal to f2y, yes, minus 3 sine 3x. Sine 3x, x is 0. So here you can see directly this sine 3x will become 0 plus f3y. Now here again 3 as it is into cos 3x, students. X is 0. 0 into 3 is 0. Cos 0 is 1. So this will become 1. So that implies f3y is equal to 0, because here minus 3 into 0 is 0. This term will become 0. Only f3 will remain. f3 is nothing but 0. This is how we have to simplify. Okay, similarly now I am going to take next condition, dou square z upon dou x square is equal to 0 when x is equal to 0. I am going to put this equation in 4, because here we have dou square z upon dou x square. So this term is again 0. Immediately you have to see Dou square z upon dou x square is 9. Look at the question. It is given as 9. So I'm going to substitute here 9. So 9 is equal to, I'm going to substitute in this equation, students. 9 is equal to, here again, minus 9 f2y. Can anybody tell me what is the value of f2y? We have to calculate it. So I'm going to take this f2y as it is. No change in f2y. Now x is 0, cos 3, x is 1. So this is into 1 minus 9. Here you can see f3y as it is, no change. Sin 3x, students, x is 0. 3 into 0 is 0. Sin 0 is 0. Therefore, please tell me what is f2y is equal to. Simplify and tell me. Yes, anybody please tell me what is f2y is equal to. Just try. What is f2y? See, this is 0 is then this full term will become 0. Am I right? Here we have 9 and here we have minus 9. So minus 9 I will bring it in the denominator. 9 divided by minus 9 is how much? Yes, it is minus 1. Therefore f2y is minus 1. When f3 is 0, f2y is equal to minus 1. Please tell me what is f1y. Just think, anybody? What is f1y? Yes, students, please tell me what is f1y. Yes, you can see here in previous slide f1y is equal to minus f2y is there, means it is minus of f2y. So here you can see minus of f2y. F2y is again minus 1 only we have calculated. So minus into minus plus. So f1y is 1. Therefore, what we get, this z is equal to, so z is the solution. Z is equal to, substitute f1y is 1 plus, in equation 1 I am going to substitute all f1y, f2y and f3y. So this is our equation, students. Just remember this. In this equation I am going to substitute f1y, f2y and f3y. Here we have already calculated f1y, f2y and f3y. Is it clear? Okay, substitute here 1 plus minus 1 cos 3x as it is, plus 0 is f3 y sin 3x. So that implies z is equal to 1. Here we can see plus into minus is minus cos 3x. So this is our PDE. This is our PDE. I have eliminated f1y, f2y and f3y. We have eliminated the arbitrary constant and we have calculated the PDE. So this is how in the exam questions will come, students. Is it clear? Any doubt, please ask me. So this completes our partial differential equation. Very, very important example I have solved today. One example you can please try. Example 3. Please try yourself, friends. Solve. Similarly, you can solve u upon 1 cube plus 4 dou u upon dou y is equal to 0 given u is equal to 0, dou u upon dou y is equal to x, dou square u upon dou y square is equal to x square minus 1 when y is equal to 0. So in last example x was 0, here they have given y is equal to 0. So the changes will be done always in the exam point of view. X will change to y, y will change to x. Here again z they have given purposely to make you confused as u. So don't get confused. U is nothing but function of again x and y, because z is a function. Otherwise you take z only and try, no problem. Otherwise you will get confused. You take z and try, no problem students. Same it is, z is equal to f of x comma y. Is it clear students? Yes. Try this example yourself students. We'll continue in the next class. Yes students, thank you so much.